there is a possibility to produce energy from the municipal solid waste. So obviously, I will try to cover that as well. Uh, when we consider municipal solid waste for energy production, so obviously there is emission factor and there are also cost related factors. So I will also cover that in my presentation. And then at the end, there will be a kind of summary and concluding remarks. So let's go to the introduction. So basically, the presentation is based on my research when I was working in Oman a few years ago. And then my research was one of my research interest is waste and resource management. And considering that research interest, I was looking to municipal solid waste as well. So the the presentation is basically are mainly based on my research, which has been conducted in Oman when I was there. So as we know that Oman is one of the GCC countries, so the situation when it's come to municipal solid waste is more or less the same in all GCC countries, which include Saudi Arabia, Oman, United Arab Emirates, Kuwait, and Qatar. Obviously, I don't want to explain this more because most of you already know the geographical condition of the GCC region. Uh, there is a main, I would say, a kind of criticism that the region is basically considered as one of the main consumer of the natural resources. Obviously, there is very good things happening here and there, but obviously uh, the GCC region is considered as a main consumer of the natural resources, and uh, there is a potential to work in these areas to reduce the dependencies on the natural resources. Right. So uh, municipal solid waste is not an issue in Oman. It's basically a global issue. Um, uh, Municipal solid waste is generated throughout the world. You can see in the graph which you can see on the slide. So it's not an issue specifically to Oman or specifically to GCC region. It's a global issues, and uh, there are different ways uh, to address these issues. Obviously, some countries are doing well, and some countries basically we can say that somehow behind. Uh, there is a population factor as well. Based on the data which I have seen, the current population and how much waste is produced in Oman per capita. So my estimate indicate that that is 1.8 kilogram per person per day. 1.8 kilogram is a quite high amount. Obviously, we'll try to see a comparison with other GCC country, but if you try to compare the whole region to the world, obviously 1.8 is a quite big amount of municipal solid waste. There is some work going on, but currently most of the municipal solid waste which is generated in Oman, they mainly go to the landfill. There are around 350 landfill throughout the region. Oman Vision 2040 uh, indicate the action plan, and it is included in the Vision 2040 that they want to improve the municipal solid waste management in the country. So the issue is basically has been realized at government level. Um, if we try to compare the population of different GCC countries and how much municipal solid waste each country is generating, so we get a kind of chart, something like that. Um, so you can see the red small triangle. That is basically the municipal solid waste, which is generated in each GCC country. So we are here in Oman. Comparatively, we are producing less municipal solid waste compared to other GCC country. So it's a good indication. Other countries like Bahrain, Saudi Arabia, United Arab Emirates, Kuwait and Qatar, they are producing much more municipal solid waste compared to Oman. Obviously, as you see in my previous slide, I have indicated 1.8. That 1.8 is coming from my data, but this data is coming from the World Bank data. So obviously, this is more reliable. Um, so the research basically start to know the composition of municipal solid waste, and for that, I have collected and analyzed around 100 sample of municipal solid waste um, to know the composition. And when I was collecting this sample, so I have considered the residential house, the restaurant, the shopping market, and things like that. I just want to go back to the slide just to say something about the composition. So if you look at to the composition, uh, there is food item, obviously, that can be used for composting. There is plastic, there is garden waste, there is textile and paper item. So the garden waste can be used in composting, and obviously the metal or the plastic waste, these are the items which can be easily recycled. So that was a kind of indication that there is a potential to explore the topic further. Uh, so when I was exploring this, so obviously I look at to that what possibility, what kind of emission is coming from the municipal solid waste. Uh, there are a number of gases that can be considered as part of the emission from municipal solid waste, but my research basically focus on the three main gases, which is carbon dioxide, methane, and that the last one is the nitrous oxide. Uh, when we look at to when I look at to the emissions, obviously the way you are transferring or the way you are treating the municipal solid waste, obviously that emission will be based on that. So if the municipal solid waste is directly going to the landfill, so obviously the estimation or the emission to calculate the emission is somehow different if it is recycled. um, so there is a guideline that is basically produced by the United Nations. It's called IPCC. So when I was calculating the emission from landfill, if the municipal solid waste is directly going to the landfill, so I have used the IPCC guideline. Um, there is an equation, but I don't want to go in detail. Maybe some of you might not be very interested in mathematical calculation, so I just leave it there. But obviously, if you want to access it online, you can simply write in the Google. And this guideline is quite simple, quite straightforward, and easily accessible. Um, so if we are going to use the municipal solid waste or part of the municipal solid waste in composting, so obviously the emission calculation will be slightly different, and that include the CH4 and N2O. These are the main gases which is coming from the emission from composting. And this is the equation which I have used to calculate the emission from if the municipal solid waste is basically composted. Obviously, the whole municipal solid waste cannot be composted. Some amount of the municipal solid waste can be composted, and that is based on the composition of the municipal solid waste. Uh, there are indications that some of the portion, not only in Oman, throughout the world, is openly burned. So obviously, when the municipal solid waste is burned, so it also create emission that is mainly carbon dioxide and methane. And there is another guideline which I have used, which is relevant to open burning. Simply, it's called ABC EIM guideline. It's a kind of inventories which is normally used to calculate the emission from open burning. Again, it's openly available. You can access it online. There is an equation which where you can simply put your data and get the emission or calculate your emission. Obviously, I don't want to explain further the equation. If you want to use it, obviously you can simply take it from my presentation or directly from the manual. So when I was looking to the emission, so obviously I said that what is happening now with the municipal solid waste and what are the possibility that can happen in the future. So I tried to develop a kind of framework. So when I was developing the framework, so for the comparison purposes, what I did, what is happening to the municipal solid waste now, that become a baseline. So whatever is happening now, that become a baseline. So whatever I'm proposing, that will become that can become like a second framework or A, B, or C framework. So whatever I propose, I try to compare with the baseline. So either it is bringing improvement or it's making the situation more worse. So I classified those framework. So the baseline framework, I just give a reference to F0 or F0, the existing approach. So what is happening with the existing municipal solid waste in Oman? Majority of them are going to landfill. There is open burning, small amount, but there is some amount which is uncollected. So obviously uncollected goes to unauthorized dumping. Um, so the framework, the proposed framework, that become the baseline. So the proposed framework, the F1, become a kind of bring a kind of improvement to the existing what is happening to, existing or currently to the municipal solid waste. So the framework F1 basically include the expansion of municipal solid waste collection. So most of the municipal solid waste will now go to landfill rather than unauthorized dumping. So the main key in the framework F1 is basically to restrict the open burning and also unauthorized dumping. Then the framework F2 consider two elements. So some of the waste basically go to the landfill. Obviously, there is no other option for that. And the waste which can be used as a compost, then it's bring the composting process. And then the framework F3, which is the last framework, it's considered the landfilling. So obviously, some of the waste directly go to the landfilling. Then it's also considered the composting, and obviously it's also considered the recycling. So some of the materials which can be recycled. When I was proposing this, so obviously some of the data which was the accurate data or reliable data, I have used that. Uh, but some of the data which is difficult to estimate, like for example, it's quite difficult to estimate how much how much waste is openly burned. So what I did, I have just looked at to what is happening in similar countries like Oman. So I have used a kind of percentage for that open burning. Uh, so you can see how much I have considered in open burning and how much I have considered in the landfilling and how much is uncollected. That is F1. Then what is happening in F1? F1, majority of the waste goes to uh, landfill. I have still considered some uncollected waste because um, my understanding that it's not possible to collect all the 100% waste. There is some amount which can be uncollected as well. Then the F2, so it's basically have the composting. So how much amount is supposed to be used in composting, then landfilling, and some obviously is uncollected. And then framework F3, composting, recycling, and then landfilling. So let's look at to the emission. So obviously, as I mentioned, that there is an equation. You can put that in the Excel sheet to calculate that emission. So this is the current scenario, the baseline framework, or which we noted as F0 or F0. So there is landfilling, there is open burning, and there is uncollected. And you can see the gases which has been considered. So mainly methane and carbon dioxide. And how much is the total? You can see here at the end. Um, so you can say that that is total equal to 2.98 um, megaton per year, and it is presented here at the end of the chart. So that was the emission from the um, uh, baseline framework. Now let's look at to the emission F1, which basically which is basically based on the improved municipal solid waste collection service. Reduce unauthorized dumping and obviously open burning. So obviously what I have considered in this, that I have just assumed that 60% has been collected. So the total amount which was classified as uncollected, I assume that that 60% of that uncollected is now collected and it is transferred to the landfill. There is no open burning, and this is what we get now. So you can the gases which has been calculated. So obviously they are methane and carbon dioxide, and there is a kind of comparison. So obviously you can see the baseline framework and then uh, the current framework, which is the F1, and you can see because uh, now, most of the waste is collected. So obviously when it's go to the landfill, so we know that how much goes to the landfill, and then it's possible to estimate how much emission is coming from it. So obviously the emission increase as compared to the baseline. And that increase in emission is around 7%. So if you look at to the existing, obviously F1 is not really good if we only focus on the emission factor. But obviously there are other advantages because you get rid of the unauthorized dumping. Emission increase, but obviously unauthorized dumping has been curtailed. Uh, Now, the F2, the next framework that is noted as F2, is based on landfilling and composting. Um, so uh, if we look at to the municipal solid waste composition, so this is the composition, there is food item, the garden, and the paper waste, which can be simply used as in composting. That is, if you look at to the total, so these item, food item, garden, and paper, and things like that, they are 64%. So there is a rich amount of waste that can be used in composting. So the framework consider those organic material, which is we said 64% of the total waste, it's only considered 50% of that organic waste or the food item so that it can be used in composting. Again, if you look at to the emission has been calculated. The emission obviously increased. Now the total emission from F2 is 3.36 megatonni. And obviously there will be an increase now because when we use composting, so obviously it's produced more emission if you compare it to baseline. So the total emission which is increased in F2, in the framework F2, is compared to F0 or F0, the emission increased by 13%. Obviously, when you want to do the composting process, so obviously it will increase the cost because you need to uh, segregate the waste. Um, you need to remove the waste which can go for the composting. So obviously it is going to increase the cost. That is another factor. So it's not only emission, but obviously the cost is possibly going to increase. The positive thing is that it can promote the agriculture activities. Obviously, Oman is not an agriculture country, but if we have a kind of things like this, obviously it can help us to promote uh, agriculture activities in the country. Um, because the waste will be used in the composting, so it will reduce the burden on the landfill. So now we need a lot of land for the landfilling, but if some waste is transferred to the composting, so obviously uh, it will reduce the burden on the land utilization. So that is a positive point of this framework. Now let's look at to the last framework, which is framework F3, which basically consider three elements. So the landfilling. So obviously there will be a waste which will be going to the landfilling. There will be composting. So the additional thing is the recycling. So the waste which can be possibly recycled. So if you look at the composition, there are some element, plastic and element are metals or the component which can be used in recycling. So uh, if you look at to the composition, so obviously there are elements as I mentioned, and those element which can be recycled is basically 16.5% of the municipal solid waste. If you look at to the whole composition, uh, obviously not all of them can be recycled, so I just consider 50% of that. So whatever is the total waste, 16.5% is recyclable, and then uh, I just consider 50%. Maybe there is a possibility we cannot recycle the whole because we're starting from the zero. So when we start from zero, so obviously we'll start from something reasonable or something which is doable. Obviously, there can be a stage which when we can recycle the whole 100%, but I just for the framework development, I consider 50% of that waste, and that is basically the composition of the waste. You can see there are metal is there, plastic is there, so obviously that can be used. Now when we consider recycling, so obviously there are different options for the recycling, how you want to recycle that waste. Um uh, I mean, we can consider different option for the recycling, but what I have considered two options. One option is the waste to energy option. So obviously uh, we can use a plant which can produce energy. Uh, so that is one of the option which I'm going to explain in more detail. It's not only for the recyclable waste, but obviously the waste which can be burned, combustible waste. So that can be also, this option can be also used suitable for that. And the second option is um, uh, material recovery facility. So if you want to take the metal or plastic, so that is basically for that what we need a kind of material recovery facility. So these are the main two options which I have considered in my research. Uh, so obviously based on the calculation, in this framework, again, we need to consider the landfilling, the emission from the landfilling. We need to consider the emission from the composting, and obviously the emission from recycling. Um, yeah, so this is the emission factor for both of the options. So one is the waste to energy option. The emission factor of waste to energy option is quite high, which is 80.3 ton carbon dioxide per year, whatever whatever emission, whatever waste you are basically using there. So the emission factor for the waste to energy is quite high. So obviously it can produce high amount of emission. So this is the emission factor 80.3, and how much emission you have considered in this option. So that is 331,213 ton per year. So that give you the total emission. Is a simple multiplication. Obviously, as I mentioned, this is a quite high emission. Um, and then there is another option, which is material recovery option. The material recovery option, the emission is quite low, which is just 1.01. So you can compare emission factor 1.01 with 80.30. So obviously you can see uh, both are quite different. There is a big difference in both emission factors. Obviously, the waste to energy option is quite will produce a lot of emission compared to material recovery facility. So the material recovery facility is just to simply multiply those element or those factor uh, and get the total emission. Now, because the waste to energy produce a lot of emissions, so the framework which I have proposed was based on the material recovery option. So if we are going to use the material recovery option, then that framework is based on that option. Yeah, so the material recovery option. So the total emission here somehow reduced if we compare to the baseline framework. So now the emission is 2.95. Yeah, so if we try to compare the framework F3 with framework F0, which is the baseline framework, so there is a difference of only 1%. So the emission basically in the framework 3 slightly reduced, just 1% reduced. Obviously, at the outset, it seems a very small, but obviously there are other benefit of this. I mean, this process. So obviously, uh, if if the focus is only on emissions, obviously it seems very smaller, but we need to think about a bigger picture. So obviously you can see uh, the industrialization factor. Uh, you can also see that when you have a waste to energy plants, obviously it can attract the investment. It can also help to create new jobs. What will happen? What will happen is basically you will create more jobs, so the employment opportunity will be created. The burden on the landfill will reduce. So obviously the land which is occupied by the waste now can be utilized for other purposes. So these are the option. I can see some question is popping in the chat. I mean, I think it will be good that if I go to those questions at the end. I mean, I'm flexible. If you want me to answer, I can answer it now.
Yeah, I
But
think I think I think give it to the because those two questions are from me actually.
okay,
But
Osam, it's you.
if
All right.
yeah, I raised those questions, so it's fine. Keep it till the end. Please go ahead. Go ahead.
So
Just
you
maybe
want?
to that. Yeah, maybe just to say to NTEs, if you have any question, might be nice if you write it in the chat, and later on we'll try to answer them. Dr. Tariq will try his best here.
Yeah, no, that's fine. Yeah, so we'll go to the question at the end. So obviously, in this diagram, you can clearly see a picture that what what each framework is producing. Um, as I mentioned that it's depend on the criteria. Either the criteria, obviously, when we have the option to choose any of these frameworks, so obviously we need to think that what each framework can bring, what are the benefits, are the plus point and the negative point of each framework. So obviously we cannot consider just based on the emission. Um, I think in the framework F2, I mentioned that the composting process can possibly increase the cost, but uh, there is a possibility that we can take the help of the resident. So when they are putting their waste, they can try to segregate it. Yes, so food item goes separate bag, and other waste which is not cannot be used in composting, that go to a separate bag. So obviously that can help. Obviously we need to increase a kind of create a kind of awareness in the resident, but obviously that is an option. So there is a possibility that when I'm saying the composting might increase the cost, yes, that is true. It might increase the cost, but obviously, if we try to develop some kind of strategies, help to bring awareness in the residents, and then use the residents to help us to basically to segregate the waste. So obviously, that can also help in the recycling as well. So maybe we can give 3 bags to the residents, and there will be 1 bag. We can use different color of the bag. So this is for recycling, this is for composting, and obviously uh, the other one simply go for the landfilling. So obviously uh, the decision should not only be based on the emission, but obviously other factor can also be considered. So this was the framework. Now let's go to the yeah. So yeah, so it's a kind of just comparison. Yes. So yeah, we are going to go to the waste to energy as well, but it's a kind of comparison. So what each bring basically, what each framework basically give us based on emission factor. But obviously, uh, a strategic decision should not be only based on the emission. Emission should be a priority, but obviously other factors need to be considered as well. Um, yeah, so that was the F naught is the baseline framework. So I just say that is 0%, uh, not more, not less. That's what's basically happening. Then F1, you bring more waste to the landfill. You restrict the open burning or unauthorized dumping. So obviously the burden on the landfill increase, obviously then it create more emission. And then framework F2 again is composting. So composting again bring more emission. That is a 13% increase when compared to framework baseline framework. And then the last one is the framework F3, which basically reduced the emission just by 1%. Obviously, it's a small amount, but as I mentioned before, that there is a number of issues that we need to consider. Uh, don't just the decision should not be taken only based on emission. Emission can be a factor, but obviously other element also need to be considered. Right. That's what actually I just explained, and that is the framework F3. Uh, as I mentioned, if we said just emission, so obviously framework is more competitive compared to other one. Right. Yeah. So as I mentioned, yeah. So if you look at to the current emission, even if you try to compare with other countries, so if we look at to the emission factor of the baseline, uh, which based on the calculation is becomes 0.65 per capita per year per tonne. Again, this is quite high. 0.65 is also quite high. The reason is that because we are producing more waste per capita, so obviously the emission factor is also quite high. Why it's high? If I just compare with some countries in European Union and also with the United States. Um, yeah, so if you look at to the F1 that produced 7% more, F3, F2 is 13%, and the last one is the F3, which is just 1%, and that 1% even is conditional if we go for the material recovery option. If we go to waste to energy plant, obviously the situation will be different. Now let's look at to the energy from municipal solid waste. Obviously we can produce energy from municipal solid waste. The reason is that why we can produce the energy from that, because if we look at to the composition of the waste, there are combustible material there which can be easily used. Now energy is is a basically an important element of our modern life. We are living in 21st century, but there are still people around 13%, if you look at to the whole globe or the whole earth, they don't have access to modern electricity. um, and if we look at to the outlook of the whole energy produced around the world, majority of that energy is produced from the fossil fuels. We can say oil and gas. Obviously, again, that is not non-sustainable way. Those resources are not guaranteed. Once they finish, then it's finished. And when I was saying that GCC region, in GCC region, we are the main consumer of the earth resources, and one of the factor is basically the fossil fuel. So that is a kind of what I would say a finger on us that yeah, we are producing, we have oil and gas, and that's why we are not going towards renewable or sustainable resources. Um, Energy is so important that it has taken a place in the United Nations Sustainable Development Goal, which you can see Goal 7 is related to um, affordable and clean energy. And there is a number of indicators that uh, the world want to ensure that everyone have access to clean and affordable energy. When we said clean, so we need to look at to the emission which is coming from the electricity or from the energy. So if you look at to goal 7, there is a number of targets, and all the countries included Oman and other GCC countries. These countries have agreed to achieve this target by 2030. So there is a number of targets related to goal 7. I don't want to go in detail, but obviously all these targets are supposed to be achieved by 2030. So there is two issues. Obviously, sustainable development goal is important for each country to be achieved. Those countries who are performing well, obviously they are on track. In GCC, there are several goals where we are not on track. So therefore, we need to think how we can achieve these goals. So I just try to consider goal 12 and goal 13, because if we are using high electricity, uh, I mean, one of the factor is that obviously we are a main producer of oil and gas, or in other words, we are in GCC a main producer of the energy, but we are also use a lot of electricity. So I just look at two goals, goal 12 and goal 13. Goal 12 of the UN Sustainable Development Goal is responsible consumption and production, and goal 13 is the climate action. And this is the situation in all GCC countries. Uh, Obviously, if we look at to the scoring of these goals, Oman has comparatively good scoring among the GCC country, but I mean, if you try to compare with other countries, uh, the score is not that good. In GCC, we are still okay because we are leading mainly the table, but obviously, um, uh, if we try to compare ourselves to other countries, there are some countries where they are doing better than Oman and GCC countries. This is based on 2019, but obviously maybe the situation might have slightly changed. So here is Oman. Uh, yeah, so what is happening? Obviously, we are producing a lot of waste, and there are many countries around the world which basically use that waste to produce energy. And I have just highlighted some of the key countries. So if you look at to Japan, um, how much energy they are, how much waste they are basically using to produce the energy. So Japan is leading that, then Scandinavia, and then Switzerland, then it's followed by the United Kingdom, then France. But obviously, we are no, the region is not in the top list. Neither Oman is there. So obviously, there is a potential that we can have a look to this and try to use that. That is a basically resource. It's a waste, but it can be a resource, and there is a possibility to use this resource to produce electricity. There are different technologies available. to produce uh, uh, energy or electricity from municipal solid waste that can be classified into three categories. The first one is called mass burn facility, and the second one is the modular system, and the third one is the refuse drive fuel system. Uh, the mass burn facilities is mainly adopted by several countries, so it's commonly used in different countries to produce the electricity. Uh, Now, if we look at to the current consumption, so obviously, as I mentioned, that we are producing electricity, or we are the energy producer, but obviously we use a lot of energy per capita. Um, so if you look at to the total population, simply what is the per capita electricity consumption, what is the total population, based on that we can simply estimate the total consumption. Um, there are some statistics which indicate that how much electricity is produced from the oil and how much is produced from the natural gas. Obviously, that is based on uh, somehow old statistic, that is 2008. But obviously, uh, if these indicators are somehow changed, obviously the current situation might be a little bit different. Um, so if you look at to how much electricity we are using, how much we are producing from oil, and how much we are producing from gas. Based on that, we can calculate how much emission uh, is coming from that electricity generation. So I have calculated the emission from oil. Obviously, again, it's a very simple criteria to use, and then uh, how much is basically produced from the oil. Then again, there is a criteria. Um, there is a criteria which can be simply adopted from the EIA database and to calculate how much emission is coming from that. So I have just calculated those emission which is coming from the oil and which is coming from the gas. And this is the emission which is coming from the gas. So I don't want to go in detail, just a kind of calculation, simple mathematics. The key element has been used, how much emission, how much electricity we are using, how much is coming from the oil, how much is coming from the gas. So let's say the current situation is changed, maybe we are producing more from the oil. So obviously that is best just to add that data to the equation, and that will give you the current scenario. So the total emission, if you consider the oil and the gas, percentage can be changed, 70%, 80%, 30%, or 20%. That can change, but obviously that is a kind of criteria. So if we look at to that, so what is coming from the oil and what is coming from the gas, obviously if we add that will give us the total emission, which is equal to 161 million ton per year. Now, if we try to look at to the composition of the waste, so from this composition, more than 50% can be classified as combustible materials, which can be used in a waste to energy plant. So my initial assumption or suggestion was to propose a 5,000 ton daily capacity mass burn unit to produce energy from the waste. Uh, there is a potential that 1 ton or tonne of municipal solid waste can produce 586 kilowatt hour. So if we if we have that kind of plant, so we can produce 2.93 million kilowatt hour daily through a municipal solid energy through an energy plant. Uh, Now, obviously, we can use that waste to produce energy, but does it has any implication on the waste, the emission as well? So again, I have calculated uh, the emission in both scenarios. So when we are producing from oil and gas, and when you are producing it from the uh, municipal solid waste if you're going to use a waste to energy plant. So I have considered that, and then I have calculated that is there is any possibility that if we have an waste to energy plant, so what will be the outlook of the emission. So obviously there is a potential, an overall potential, considering the overall emission from the municipal solid waste, there is a potential to reduce the total emission for a year if we have a municipal solid waste, um, if you use municipal solid waste in energy production. There are other factors that need to be considered. So it's not quite simple. Yes, that okay, yes, it look nice that oh, emission has been reduced, but obviously there are other factors that need to be considered. So obviously the initial cost, there has to be when we said a 5,000 ton plant. So obviously that plant need to be made or established. So the initial cost, if you look at to the statistic, that can be 200,000 for daily tonning capacity. So whatever is your capacity, if your capacity is 5,000, so you need to multiply with 200,000 US dollar, you get the total cost, rough cost, obviously. So if you want to calculate based on 5,000, so that will be the cost. There will be an operational cost as well. So when we calculate the operational cost, obviously we consider that cost per tonne. So some statistic indicate that that can be um, $30 per tonne. So uh, that is another cost. If we look at to a 5,000 tonne capacity plant, so obviously we need people to work in that plant. So what will happen, around 300 people employment can be generated. Um, but obviously when 300 people will be working there, so obviously we need to pay their salary as well. Um, the salaries can be different, but obviously a rough estimate can be 4,500 per day, depending on their salary scale. Again, obviously, we have other renewable resources. I mean, we have a greater potential of solar in Oman. We have a greater potential of other form of renewable energy. There is a potential on wind energy as well, geothermal energy as well. Uh, so if you look at to the waste to energy plant, the statistic indicate it's somehow costly. So obviously that cost element need to be considered, but there are other long-term indicators which might be useful if a strategic decision need to be taken. Right. Uh, I think I speak a lot. I'm just going towards the concluding remarks. Uh, as I mentioned, that there are a number of challenges associated with municipal solid waste. It's not only related to Oman, it's not only related to GCC. This is a global issue. Obviously, we might not be in a good position compared to other countries, but it's a global phenomenon, and each country is trying to address that in a different way. And there is a potential for Oman to address these issues, obviously. Yeah, so one of the factors which we have considered is the emissions. So different frameworks, uh, framework 1, framework 2, and a framework 3. There is a possibility to create another framework as well. Um, and each framework have different emission, and obviously that have different impact on the land utilization. Uh, Obviously, there is unauthorized dumping. Unauthorized mean that it's not a major issue in the context of Oman, but obviously is still an issue at a global level. Composting obviously increase the emission, but it can help to promote agriculture activities and also can help us to promote uh, to reduce the burden on the landfill. So that land can be used for other purposes. Um, Recycling can be done in different way. It can be done through uh, material recovery plant, or it can be done through a waste to energy plant. So in the framework development, I have considered material recovery plant, which basically have some positive impact on the total emission. Um, Recycling also can increase the cost, but obviously the public participation, the resident participation can help us to control. We need to simply do a kind of awareness session with the resident, motivate them to participate in the recycling activities like uh, separate different types of element in their waste, and then help us to collect that separately. So obviously that cost can be reduced. As I mentioned that if you look at the composition of the municipal solid waste in Oman, so 50% can be used in an energy waste plant. Uh, what will happen? We will not only produce uh, energy from a waste to energy plant, but obviously we will also reduce our dependency on oil and gas. So that is a positive. That is a positive aspect which we can consider. Uh, Obviously, when we look at to the cost of electricity production from a waste to energy plant, and if you try to compare with solar or other renewable forms, obviously the cost is still high. There might be new technologies coming in future that might help us to reduce that cost. Um, there are some publication which is basically based on my presentation was basically based on these publications, but obviously if I have missed some points, obviously it is a good resource, and if somebody want to read these resources, they are available. There is a web link to that publication as well. So it's a good papers to read, particularly if you are interested in municipal solid waste. I would say thank you very much for your attention. I will start the question and answer session. So obviously, feel free to ask question. Hussam will definitely allow you to ask question. Uh, you can also write to me if you want to get in touch. I have provided my email. So my email is just my name, tariqumar1984 @ gmail.com. If you want to get in touch through social media, so obviously I use social media, I use Twitter, I use LinkedIn, I use Facebook, and there is a web page as well. So my contact details are there. Thank you very much for your attention. Obviously, I think I have spoken for 1 hour, so obviously you might have questions. So I'm happy to answer that. Thank you very much.
Thank you, Dr. Tariq. It's a very insightful presentation with a lot of knowledge about municipal solid waste, its emissions, as well as global warming potential. Uh, I think if anybody has any questions, you could raise your hand. Valentina will actually be able to unmute those who have any questions. If not, then I will see the questions in the chat. There's actually just two from me, and there's one from David Kanyugo. Yes,
Uh,
please, can we get these slides after the presentation? I don't know, that's up to the speaker, really.
yes, I think definitely I can provide this to the organizer, Hussam, or and then maybe or David, if you want to get in touch with me, I'm writing my email in the chat box. So if you just uh, write an
If you,
email, yeah, I will be definitely able to send that to you.
yeah, if you want to share it with the attendees, Dr. Tariq, you can share with Valentina the slides, and she'll be able to cascade later on.
All right, that's absolutely fine. Yes.
Yeah. Yeah. Okay, somebody raised hands. I want to keep my questions to the last just to give opportunity to people to ask any questions from Mohammed Hamza.
Hi,
Uh,
so Dr. Tariq, very interesting presentation. Thank you for that. I just want to ask, you have mentioned the price for solar and fossil fuels per megawatt hour. Do you have that figure for the energy from the municipal solid waste? how much dollar per megawatt hour, just for apple to apple comparison?
So it's basically the statistic which I have taken for the municipal solid waste that is coming from the EIA, but obviously when you want to establish a plant, so you need to look at to the local economic. So uh, that is very important. I have given you some indicator that what would be the cost of a plant when you want, let's say you want to go for a municipal, waste to energy plant. So what would be the cost? So that cost is basically base the initial cost, the production cost of the plant, or the construction cost of the plant. So that cost is initially based on the capacity of the cost, which I have indicated in my slide. Then you have operational costs. So you need to consider that as well. So whatever is the capacity of your plant, so per each tonnage, there is an operational cost. And then uh, based on the capacity, um, there will be people working in that plant. So obviously you need to consider their salaries as well. Now, if you are looking to Oman, so obviously the salaries can be different if you consider the United States or let's say another country. So I think we need to make that clear that what is the capacity of the plant, what plant you want to establish, what would be the size of that plant, and based on that we can calculate the actual cost which is coming from the for the purpose of comparison. But obviously there is some statistic which I have quoted, the EIA statistic, which basically provide a kind of comparison, but that cannot be true or reliable in each country. Each country has its own dynamics and
Okay.
economics.
Okay, thank you. Just one question on your framework. In framework 3, you have included composting, landfilling, and recycling, whereas in framework 2, where it's the only composite, you include only composting. So
Yes.
the emissions were higher in framework 2, whereas emissions are lesser in framework 3, where you have composting still included. So what is the reason?
So basically what happened when you include composting, so what happened, and then you include the recycling as well. So what happened, the overall burden on the landfill basically reduce. So the emission from the landfill basically reduce. When the emission of landfill basically reduce, obviously waste is there, you just distribute it. And when you distribute it, so obviously the material recovery option has less emission compared to the landfill or the composting. So that's why it's reduced, and it's reduced only by 1%, which is not that significant, I think.
Thank you.
Are there any other questions from attendees? Well, until somebody raises their hands, and I'll ask you a few questions, Dr. Tariq.
Yes, please.
Yeah, actually, that option that you have, I think it was framework 2, if I recall correctly, it had an option of no open burning compared to the baseline. So does that mean in that option a controlled flaring is being done, such as like from engineered fill?
So that is basically framework F1.
Yeah,
So um, the problem is that uh, it's not uh, there is no clarity basically. And
yeah, that's
when
why I
I
was
was
asking. Yeah, yeah,
yeah, when I
yeah.
was doing this research, so I was asking a question from myself that how much waste is burned in Oman, right? Uh, Open burning take place, right? But the
Yeah.
problem is that getting that accurate data is not possible,
Yeah.
right? Because that is, so somebody maybe burn something in their home, they just want to get rid of it. And when I was living, I did that in my home, right? So, uh, so when I said how we can control that, so when we said unauthorized dumping or unauthorized waste, so is basically that waste that is either burned or is just dump in unauthorized location. So when I was doing this research, so I look at to a kind of global scenario, and I just try to compare the countries which might have some kind of similarities with Oman. I look at to that countries and I look at to those data, and I try to see that how much waste is burned there, and then I consider those value. So open burning is a quite critical to arrive on a accurate or reliable figure, but obviously there is an open burning element in the baseline, and then in the framework I said no open burning. So that means that waste which I
It's only
consider in the
controlled burning in that
yes,
case, is it? Yeah.
yes,
Yeah.
yes.
Okay. Okay, clear. Thank you. Then I had another question, which was about the emission factor for the waste to energy plant,
Yes.
which you mentioned that it's quite high. I think it's about 80 tons of CO2 equivalent, if I recall the
Yes,
number
yes,
correctly, yeah,
yes,
compared to the recycling option.
yes.
But that is really dependent on the plan design, right? I mean, there could be so many options and solutions to bring that figure down, where you might have a waste to energy plant that's quite efficient, depending on the capital invested.
Yes, this is true. So that is like the guided value, and obviously that guided value is coming from uh, the research which has been done by other people. So that is the guided value. Um Technology is developing, technology is advancing day by day. So there are possibility that there might be latest technologies which might help us to reduce that emission factor down. So for comparison purpose, obviously the research was a kind of exploratory research. So that value has been used in the research, but obviously uh, there are some efficient plant which can give you lower emission factor. So yes, that should be considered. Yes. So when I said 80, so obviously that is not like a cost in stone. You need to look at to the
Yeah,
technologies
yeah,
in
yeah.
use and things like that. But the mainly plant are the common plant which basically use their emission factor is more or less currently 80 or maybe uh, around that figure. Uh, Obviously, the technology is improving, so maybe in future we'll have some plant which might have lower emission factor.
Yeah, it's a very important number for business case of building such plants as well. Yeah.
Correct. Yes.
Yeah, I just wanted to only mention one last thing, and there's two hands actually raised. We'll ask them the questions, so they can direct the questions to you.
Yes.
But I wanted to highlight, actually there was something I read recently, and maybe to tell the attendees as well, that BIA, the Oman company responsible for managing municipal waste, actually signed an agreement. I think it was in March when I read it this year, where they're going to build a waste to energy plant in Barka with the Oman Power and Waste procurement company, actually. So that's a good news for Oman, and could
Yes. This is
be, a trial for upcoming ones as well, across the country.
yes. I mean, this is very great to know. Obviously, I'm glad to know. Yeah, I think B is doing some good things, but obviously there is always a room for improvement. So I think that is a good initiative. Uh, Waste to energy plant is not going to give us clean energy, but obviously
Better,
yeah,
cleaner,
yes,
cleaner,
yeah,
not fully
yes,
clean. Yeah,
yes. So this is something very good to know that there is a plan basically. Yes. um, yeah, this is very interesting to know.
yeah, yeah. I just want to mention that. Okay, we have a question. We have Tas who has raised his hand. You can unmute yourself, I guess.
Yeah. Um, Good evening, doctor. My question is a very basic one. In all the presentations, I hear about the emission, the quantity of the emissions and the proportions of the emissions, etc. But where I'm struck is with all the huge emissions, the proportion, the when we look at the air proportions, the proportion of, for example, the atmospheric composition doesn't vary. So why is it so? So if the emissions is so huge, why is the air composition is not varying so much? For example,
Sorry, I didn't
we,
get the. So why? What is not varying?
the atmospheric composition, for example, the proportion of nitrogen, oxygen, all this composition, it is not varying, even though we are worried about the huge emissions from every aspects.
No, I think it's varying. But what happened when we calculate, let's say, when we calculate the other gases? So what we try to do, we try to translate that into CO2 equivalent. So maybe that is a kind of creating a confusion. But obviously, um, the gases which has been produced in different scenario, ultimately they have been translated or converted into CO2 equivalent. So maybe that is a kind of confusion. But obviously, when the scenario change or when the framework change, so the emission factor or the overall emission is basically changing. Um, and I think that was clearly evident by the chart which I have presented. So obviously there is a clear indication that things are going up and down. When you look at to the baseline, obviously baseline we are not doing anything. But when we look at to the framework F1, so obviously we said now more waste is going to landfill. So when more waste is going to landfill, obviously we'll have more methane. So the emission is going to increase. When we bring composting, so obviously the composting process is a chemical process. Obviously, it's a natural process, but during the process, the emission is comparatively high. So the overall emission from that framework is increased. And I think that has been quite clearly evident in the comparison. So when we said framework, framework F1 increased 7%, F2 increased 13%, and then F3 basically reduced by 1%. So obviously that was based on the calculation. Uh, I don't understand where was the confusion and how you arrived that the emission uh, was not changed, but obviously there is a change there.
Uh, um, where I was, my doubt was not about your data, but when we look at the atmospheric composition of different elements, for example, in atmosphere we have the nitrogen, oxygen, carbon dioxide, etc. The
Mhm.
proportion of those elements in the atmospheres is not varying, even though we are experiencing huge emissions from various industries around the world.
All
But
right. So
why?
yeah.
Maybe I could interrupt just a second. If you see Dr. Tariq's presentation, where he talked
Mhm,
emissions in terms of CO2, CH4, which is methane, and in NO2 as well. NO2 and CH4, these have global warming potential. The global warming potential actually for these is quite high compared to CO2 itself. Even though maybe quantity or volume is small, but they might have 200, 300, 400 times the global warming potential of CO2. I think maybe
I
that
think
that will maybe cover the concept. Yeah.
No, I think
um,
that the question is coming clear to my mind, that I think
yeah,
he's trying to say that if we take a sample or if we try to measure in the open environment these
yeah,
gases, so that
yeah,
is not changing.
yeah.
Um, Obviously, we are living in one world. Uh, so if we look at to the environment, obviously there is a natural cycle, right?
Yeah.
So uh, maybe uh, precipitation is happening, or let's say the water cycle is taking place in Oman, but the rain is taking place in Malaysia, right?
Mhm.
So obviously this is an open environment. So maybe whatever we are producing and whatever is emitting in the atmosphere, uh, it might not be. accurately represented from the sample if we take it from the open atmosphere, because obviously that is uncontrolled environment, right?
Yeah.
But obviously there is an impact. Like for example, you can simply say this in that way. If you look at to the global picture, so there are some countries who are basically the main emitter of emission, who produce a lot of emission, right?
Mhm.
But if we look at to the consequences of that emission, that country might not be affected. There are other countries in a different part of the world, they are affected from that emission. So something is produced at one place, the emission is produced at one place, the consequences of that emission may not be impactful there, but it might impact the other word. So it's basically the one word. That's why the UN Sustainable Development Goals. So I think in that case, your question is valid. So you need to keep that in mind, that it's an open environment. It's not human controlled environment. So obviously there is wind there is rain cycle there, which basically change the situation.
But if in an overall picture, if all these emissions are cannot make the composition change, so do we need to really worry about the emissions? I
We
know,
need
I
to.
know, I am going against the tide, but this is a serious question. I always have, even I always have a whether this is right or wrong question.
Yes, I think this, I don't know, I don't want to say it's right or wrong, but obviously we need to worry about the emission, because you need to keep in mind we have only one Earth to live. There is a plan to live on Mars, but it's going to take some time. So at the moment we have one Earth to live, and obviously that Earth has now a number of challenges, global warming, climate change, and that is the result of the climate change, obviously, and that climate change is basically taking place because of the emission, or the greenhouse gases we are producing. So either it is produced by one country or another countries, there is an impact. So uh, uh, I don't think that there is no consequences. There is consequences, and we are looking to those consequences. We are seeing those consequences, but sometimes we just ignore them. We said, "Oh, it's not my problem. It's a problem of another countries or things like that." So there is a great impact of this emission. Either it is visible at your place or in your countries or not. That is a separate issues. But there is, and the world or the world leader are basically worried about that. So it's not me or you basically. That's why we were having just recently COP27 in Egypt, and we have these UN Sustainable Development Goal. There is issues. What is happening uh, in the North and South Pole? How the Earth temperature is increasing. So obviously these are the issues. There are studies which basically indicate that if the situation go in the same way and if we don't control it, so what will happen? We will not be able to live in the GCC region. The temperature will reach to a level where our AC will be there, but we cannot go outside. So obviously we'll not be able to live in that region if we don't control the situation. So obviously the situation is quite alarming.
Okay. Yeah. Okay. Thank you.
Thank you, Tas. We have a question from Zing. Please, you can go ahead and mute yourself.
Hello, Dr. Tariq. I have a question. I've read a report recently that Oman is the first in the region for air pollution. So I was wondering if we can amend the facility with carbon capture and storage. Is it a good way to reduce emissions? Because some might argue it's ineffective and unsafe. What are your thoughts on that?
Yes, I mean, if you look at to the Oman, maybe our ranking in the GCC region might be comparatively good. And as I see in my slide, also I said, oh, we are good because we are producing less less municipal solid waste. But when we go further and when we reach to compete the other GCC region, like for example, as I mentioned in my slide, UAE has a quite higher uh, uh, per capita of municipal solid waste. Now, what is the reason? Obviously, there are some reasons. So maybe we are not have yet reached to that level. So maybe our current performance is okay. We said, oh, we are comparatively better, but obviously industrialization is taking place. New industries is going to come. Uh, our environment is changing. The way we are doing the things are changing. More construction, more population. So obviously it is going to affect. And there will be a stage when we will be leading, or when we will be just coming back to the actual situation where other GCC countries are there. So whatever solution is there, either it is carbon capture or anything which basically help uh, not only the emission but also uh, the other sustainability elements that will be useful. So when we consider sustainability or sustainable development, what we consider, we not only consider the environmental factor. So in terms of emission, that is more related to environment, but obviously we need to consider the economic factor, and we also need to consider the social factor as well. So whatever is going to help the Oman, that can be implemented or that can be adopted. There are other countries who basically use that technologies, and basically that brings some kind of positive impact uh, on the overall sustainability of the country. So obviously that can be an option. Uh, Anything which can help the situation, which can help the sustainability factor, I think that should be used. But as I mentioned, when we are going to take the decision, it's not only based on one element. We need to consider other elements as well.
Doctor, I have another question.
Yes.
So for the incineration facilities, um, it doesn't just produce electricity, waste to energy. It also produces heat. So you know the region, it's hot, not like the ones we saw like Japan and whatever. So in the summer, what will happen in the case of overproduction of heat? Like
So basically that heat will be basically used to generate the turbine and produce the electricity. So that heat basically is going to use the electricity, and obviously it will have some contribution, but the plant will be at one location. Um, we have a lot of open area where uh, the plant can be helpful, and obviously there will be environmental impact assessment. So there are strategies which can be adopted. The plant will also produce emissions, so maybe plantation will helpful in that. So when there will be a feasibility study and when the things will happen in reality, so we need to ensure that we incorporate some strategies that can help uh, the pollution, or uh, I mean that can also help to maintain a sustainable environment. So maybe the best thing is to have a kind of plantation. So any company want to produce that plant, the government should negotiate with them that, okay, you are going to do this plant. This is a good plant, but obviously there are some negative aspect of that. So how you are going to those negative aspect? So then the company need to provide how they are going to curtail those negative impact. So obviously one thing is to plant more trees. When you plant more trees, obviously that is the option to curtail those negative impact.
Also, I want to add one thing about this heat generation question from the attendee. There are also, like in power plants, they use systems like closed cycle turbines and heat recovery steam generators as well, which recycles part of this heat back into the system and make it even more efficient and produce less emissions as well. So there are a few technologies in turbine systems as well, yeah, rotating equipment.
Yeah, thank you, Hussam, for adding that.
Yeah, I think we don't have any other hands raised. I think we'll be able to conclude actually.
The-
Just four
Uh,
minutes left here.
yeah, I see two hands up. Okay, so these
It's
were
the same.
the
It's the same
okay,
individuals.
okay, all
Yeah,
right,
yeah,
okay.